Video opens with dramatic footage of a snow-covered frozen city. News clips show reporters bundled up, discussing record low temperatures. Hey everyone, and welcome back to the channel. Do you remember the winter of 2019? It felt like the entire country was thrown into a deep freeze. In the Midwest and Northeast, temperatures plunged to insane lows, hitting a staggering -63 degrees Fahrenheit. It was pure chaos. Flights were grounded by the thousands, power grids strained under the demand, and cities basically shut down. It felt like a scene straight out of a disaster movie. But what was behind this nationwide freeze? The culprit has a name you've probably heard: the polar vortex. So, what exactly is this polar vortex? Imagine a massive, spinning top of super-cold dense air that typically stays parked right over the North Pole, held in place by strong winds called the polar night jet. Think of it as a natural refrigerator for the planet, keeping all that frigid Arctic air contained. Normally, it just does its thing way up north, minding its own business. But sometimes, this spinning top gets wobbly. It can stretch, split into smaller vortices, or even get knocked completely off balance and wander south. And when it wanders, it brings a piece of the Arctic with it, unleashing brutal cold snaps on unsuspecting regions like North America and Europe. That's precisely what happened in 2019. The vortex weakened and stretched, allowing a lobe of that intensely cold air to sag down over the United States, leading to those record-breaking temperatures. Now, here's where it gets really interesting, and frankly, a bit concerning. Scientists have noticed that the polar vortex has been acting, well, weird, especially over the last 20 years. These extreme cold events, once considered rare, seem to be happening more frequently and with greater intensity. You might think, wait, isn't the world getting warmer? And that's the paradox. It's counterintuitive, but a warming Arctic may actually be a key driver behind these colder winters in the mid-latitudes. Let me explain. The Arctic is warming more than twice as fast as the rest of the planet. This rapid warming reduces the temperature difference between the frigid pole and the warmer air to the south. This temperature contrast is what fuels the jet stream, the high-altitude river of air that circles the globe. Think of the jet stream as the fence that pens in the polar vortex. When the temperature difference is large, the jet stream is strong, straight, and fast, keeping the cold air locked up north. But as the Arctic warms, that temperature difference shrinks. This weakens the jet stream, causing it to become slower and wavier, kind of like a meandering river instead of a straight canal. These big, loopy waves are what scientists call Arctic oscillations. When the jet stream develops these deep north-south waves, it creates a pathway. It allows that frigid Arctic air, the stuff that's supposed to stay in the polar vortex, to spill southward. At the same time, these waves can pull warmer air northward into other regions. This wavy pattern can get stuck in place for days or even weeks, leading to persistent and extreme weather patterns. So, when one of those big, wavy dips in the jet stream parks itself over North America, it acts like an open door for the polar vortex. It allows that pocket of Siberian-level cold to plunge down into places like Chicago, New York, and Boston. Suddenly, you have temperatures that are more typical for the North Pole than for the northern United States. On the flip side, the upward arching part of the wave might be bringing unseasonably warm weather to Alaska or Europe at the same exact time. This is why you can have record cold in one part of the world, while another part experiences a heat wave. It's all connected to the stability of the jet stream and the polar vortex it contains. The behavior of these massive atmospheric systems is a delicate dance, and it seems our changing climate is disrupting the rhythm. The big question everyone is asking is the polar vortex getting stronger? The answer is a bit complicated. The vortex itself isn't necessarily getting stronger in terms of its wind speed all the time. In fact, it's the weakening of the vortex and the containing jet stream that often leads to these southward plunges of cold air. When the vortex is strong and stable, it stays put over the pole, and we tend to have milder winters. It's when it's disrupted and weak that it wobbles and sends its cold air southward. So, what we're really seeing is an increase in the frequency of these weakening events. Researchers are actively studying the links between Arctic sea ice loss, Siberian snow cover, and these vortex disruptions. The evidence is mounting that the rapid changes in the Arctic are making these polar vortex breakdowns more common. This means we need to be prepared for a future with more weather whiplash. Winters could feature long periods of relatively mild weather, punctuated by sudden, severe, and prolonged cold snaps. This has huge implications. It affects our infrastructure, from power grids and water pipes to transportation systems that aren't built to withstand sustained, Arctic-level cold. It impacts agriculture, with late-season freezes threatening crops. It also affects our energy consumption, as demand for heating skyrockets during these events. Understanding the changing behavior of the polar vortex isn't just an academic exercise for meteorologists. It's as crucial for planning and adapting to a world where our weather is becoming more and more extreme and unpredictable. The calm, predictable patterns of the past are being replaced by a new, more volatile reality. So, the next time you hear a forecast calling for the polar vortex to visit, you'll know exactly what's happening high up in the atmosphere. It's not just a cold day. It's a massive, planetary-scale system being nudged out of place, bringing a taste of the Arctic to your doorstep. The connection between a warming Arctic and colder winters in some places is a stark reminder of how interconnected our planet's climate system truly is. The chaos of 2019 might not be a one-off event, but a preview of the new normal for winter. Thanks so much for watching. It's a complex topic, but I hope this helped clear things up. What are your thoughts on this? Have you experienced one of these extreme cold snaps? Let me know in the comments below. If you found this video informative, please give it a thumbs up. And don't forget to subscribe and hit that notification bell so you don't miss our next deep dive into the science that shapes our world. Stay curious, and we'll see you in the next one.